All right, guys, practice test 20. Let's do this thing. Number one says graph that function, take the domain, range, and the asymptote. So first of all, I see a -2 on the outside. That means it's been shifted down 2, so I'm going to asymptote down 2. Usually I go 1 above the asymptote, which I'm going to do, but the exponent has a +3 in it, which just means you go left to right opposite what you think. So I'm going to go up 1 and left 3, so my point's going there. And then I'm going to go 1 to the right and go up 2.71828 from the asymptote, because that's the value of E, 2.71828. And there you have it. The domain, all reals. The range is going from -2 to infinity. And the asymptote is y equals -2. Your asymptote and your range will always have the same number inside it. Number 2, the population of a certain species of bird is limited by the type of habitat required for nesting. The population behaves in this sort of model. That's logistic growth, by the way, where T's measures. Find the initial bird population at time 0. Now, I'm not going to work this one out. Well, I guess I am. If I put 0 right there for T, sorry, the E becomes 1 because it'd be E to the 0 power. Which means my denominator is going to be 0.5 plus 27.5, which is 28, by the way. So I'm doing 5,600 divided by 28. And I'm getting 200 birds at time 0. Then it says after 3 years. So after 3 years, I'm just going to put the 3 into that exponent right there. And I'm going to tell you what I'm punching in, even though I can't really show you on the video. So I'm doing 5,600 divided by, open parentheses, 0.5 plus 27.5. E, I'll always open another parentheses, -0.044 times 3, close that parentheses, close the big parentheses, hit enter, and I'm getting 227 birds. We're not going to round animals. It's kind of weird to do that. So whatever the integer part of your answer is, that's what we'll go with. Number 3, a radioactive substance decays in such a way that the amount remaining after T days is this function. Okay, find the mass at time 0. So again, I'm not going to punch that in. I'm going to put 0 right there. When I do that, the exponent becomes 0. E to the 0 power is 1. 1 times 6 is 6, so I start with 6 kilograms. Then it says how much is left after 20 days. So I'm just going to put the 20 into my exponent like that. And I'm going to punch it straight into my calculator. 6e to the -0.087 times 20th power. And I'm getting 1.05 kilograms. You should get the same thing. Number 4, if $6,500 invested at an annual interest rate of 7.25% per year, compounded, here's the key word, continuously, find the value after 12 years. So because it's continuously, I'm using PERT, P-E to the RT power. So I'm going to have 6,500 times E to the 0.0725 times 12 power. I'm just going to punch that straight in like I've been doing. 6,500 E to the 0.0725 times 12. Sorry, I'm punching this in while the video is running. Probably not the best thing. So I'm getting $15,514.92. And you should get the exact same thing. All right, 5 and 6, graph these exponential functions. There's no E, it's a 2. And because there's no shift up or down, the asymptote is at the x-axis. I'm going to go up 1, right 3 because of the -3 in there. I'm going to go 1 to the right. You can either plug in 4 in there if you want to, or just remember that if the number's 2, it means you're going to go up 2 from the asymptote. You can connect those dots, la, la, la. And there you go. This directions didn't say to do domain arrange all that stuff, so I guess we're okay. Number 6 has a -2 on the outside, so the asymptote is going to go -2. Also, it's 1/3 in here, which means I'm usually going to do decay, but, sorry, there's a negative exponent, which is going to flip that. So it's really this. It's really a negative in the front, 3 to the x power -2. So I'm going to go, instead of up 1, I'm going down 1 because of the negative sign in the front. That flips it across the the x-axis, or in this case, the asymptote. And then I'm going to go 1 to the right. And if I go 1 to the right, and if I plug in 1 up here, it gives me -3 minus 2, which is -5. And I should have known that. It would be 3 below the asymptote because the number was 3. And there's the graph. Number 6. All right, number 7. A certain breed of mouse was introduced onto an island with an initial population of 250. Wonder who introduced those. Like, what was the purpose of doing that? And scientists estimate that the mouse is doubling every year. Sorry, the population of mice, the mouse population. Okay, find a function that models the number of mice in 2 years. So, part A, we go y equals a to the t power, where a represents the initial amount, and sorry about that, I actually just messed that up. Let me start that one over again. Welcome to live video. This is how it works sometimes. Yeah, like I said, it's a r to the t power, where a is the initial amount, r is the rate that's increasing, and t is the time. So just to write the model for part A, I'm going to say y equals 250, because 250 is the initial amount of mice. It's doubling, so the rate of growth is 2 to the t power. And there's part A right there, just the function. Part B, it says after 8 years, so all I'm going to do for part B is I'm going to punch in 250 times 2 to the 8th power into the calculator and see what happens. Be careful when you do this. I guess if you'll just type it in just like you see it, it'd be okay, especially if I could actually do that. I'm struggling today. Sorry about this, guys. I'm getting 64,000. That's a bunch of mice. Not sure why anybody would do that. Number 8. An investment of $8,000 is invested at an interest rate of 4%, compounded quarterly, which is important. How much is this worth after 7 years? So I'm going to say, okay, the final amount is the principal, 8,000 times 1 plus R over N. The rate is 4%. N is quarterly. Quarterly is 4 times a year. And my exponent is going to be 7 times 4, or 28. So I'm going to punch that straight in like I've been doing. I keep saying, punching it straight in. 0.04 divided by 4 raised to the 28th power. And I'm getting this much money. Wow, that's $10,570.33. So almost $2,600 of interest in 7 years for doing absolutely nothing. Number 9, what would the value of investment number 8 be if the interest rate was 3.6% compounded semi-annually after 9 years? So same formula. Some of the numbers have changed, obviously. 3.6%, I'm going to change to a decimal. It says semi-annually. Semi-annually is twice a year. It says 9 years. That's 2 times 9, or 18 in my exponent. So let's punch all that in. I'm sorry about this. I know this is a great video. Listen to me punch my calculator. Okay, and then $11,029.35. All right. Number 10, express that in exponential form. Remember, you take the base to that power equals that. So I'm going to say 8 to the 2/3 equals 4. And this is easy because what you write should be true, right? 8 to the 2/3 power is true. If it wasn't, you shouldn't write it. Write that in log form. Log, whatever the base is up here is also the base down here. So it's base 81. And remember, with a log, the exponent is the answer. So the answer is 1/2. Number 12, log base 464 is basically asking you 4 to what power is 64? 4 cubed is. The answer to a log is the exponent. The answer to a log is the exponent. This one says, oh my gosh, 5 to what power is 5 to the 7th? I'm going to say that one more time. 5 to what power is 5 to the 7th? Are you kidding me? The 7th. And part C, 5 to what power is 1 over 125? First of all, it's been flipped. Remember, the answer is the exponent. A negative exponent flips the 5. So now it becomes 5 to what power is just 125, and it's the 3rd power. Hopefully that made a little sense there. It's got to be negative because it's been flipped. And the last one, sorry about that. Number 13, sketch the graph of the polynomial function. Make sure that your graph shows all intercepts and exhibits a proper end behavior. First of all, there's 3 x's, and it's positive. So it means it's going down, left, up, right. I have a 0 at positive 2. A 0 at negative 4, and a 0 at positive 1. There's no bouncing because there's no even exponents. Remember, it's going down, left, and up, right, so it's coming out here. It's going to go through there, bounce back. There it goes. I shouldn't have used the word bounce right there because it doesn't bounce off the axis. But anyway, there's your graph. Hope that helps. The test doesn't seem too bad to me. Hopefully you got a great chance to make a great score. See you tomorrow when you come in and make your 100. Adios.